So hello everyone, so I'm Maxence Beaumont. Today I will introduce to you AI in video games. So this will be through practical case of relation between AI and games. So first of all, who am I? Well, as Jules said, I'm a French game developer. I'm 23 years old, and after graduating from a master in game design and programming at Isard Digital in Paris, I started working for OBB as a junior gameplay and tool programmer. So before we begin, the uses of AI in games are numerous. I will only treat few examples of what we can do in AI or what can games bring to AI research. Basically, the main goal of AI uses are reducing the complexity and manpower to do tasks, enhancing realism of a game, and also optimize some games. So the first example I will talk about is like use of AI in animation. So basically, traditionally, animation handling in games can be really messy. Um, Sometimes it uses real complex diagrams, which can lead to confusion. So this picture represents the animator in the well-known game engine Unity. So this animator uses a state machine, and it's the most common way to handle animation in games. So basically, to simplify the use for users and animators, we can use neural network to handle which animation to choose. So first, we need to simplify data handling with tags. So as you can see in the picture, the whole state machine was turned into some tags, which gives a propriety about the character, as for instance, its gender or what kind of action he's doing, the angle, etc., etc. All these inputs are transformed in a mathematical function which uses a list of number x and returns a list of number y, which is the position of each joint. As in animation, I'm talking about 3D animation. It's often handled by a skeleton. So the y's are the position of each joint of this skeleton. So in the previous example of GDC, which is the Game Developer Conference, you can see the x's are transformed into y's and gives you an animation. So unlike in animator like state machine, new variable can be easily added. It will just add another x to the pile. So in the previous example, X and Y's database is filled through supervised learning. Then to get the animation, they use regression to get the proper Y given an X. So the function used to get the proper animation given an X is called nearest neighbor regression. So the second example is AI-based rendering, and more particular, the Nvidia Dlss. So what is the DLSS? DLSS uses it's an AI-based anti-aliased upscaler, proprietary of Nvidia. So it uses the neural graphic network NGX, and it is trained on an Nvidia DGX supercomputer. So how it works and how it is trained. So first, the the Nvidia supercomputer will render a high resolution ground truth anti-aliased, and then it will be trained by giving rendering low resolution aliased render of the game. Then it will go to a convolutional autoencoder, and it will give a 4K like anti-aliased output, which will be compared to the ground truth. And if the comparison is like if good enough, it will go back to the autoencoder and be used to render the next frame, which optimized a bit the process. It will also give the autoencoder a motion vector, which gives the position of each vector in time, of each pixel in time. It's equivalent to an optical flow. So what is NGX? Well, basically NGX is a deep learning based technology stack that acts as a core for any AI-based graphic enhancement. Also, it requires RTX Nvidia tensor cores to be able to compute. And it also requires a trained neural network in order to complete tasks. DGX is the Nvidia full stack solution for AI development. These are optimized servers in which you can work with AI. You can do tasks like deep learning or data science algorithm. Also, Nvidia offers those solutions to companies outside of Nvidia for their own work. So the goal of this Nvidia Dlss is to be able to render the game faster at higher resolution while keeping detailed graphic. Sometimes it's pretty complicated to have a high resolution rendering of the game without it having some issues and run really slow. So how does it work? The game engine sends a low resolution aliased rendering as input, and the train agent will convert it to high resolution anti-aliased rendering. So it is mostly possible, as I said before, thanks to the new tensor core architecture that are optimized for AI and presenting the new Nvidia graphic cards starting like RTX 2060. So this process must be done for every game. And when the agent is well trained, Nvidia will deploy a new patch game ready, which has the new drivers for the graphic cards, but also the trained agent for each game they run through. So now, on a different topic, how can game help AI research? So I will talk about the example of AlphaStar. What is AlphaStar? It's a Deepmind, Google Deepmind based AI, which plays StarCraft 2 and can beat pro players. So here is a small video, which is some highlight of the games between AlphaStar and some pro players. So basically, why StarCraft 2 is challenging for AI studies? First, the theory. StarCraft 2 implies a lot of various and complex strategies, and there is no unique solution to win the game. Also, the lack of information can be really challenging for AI because in StarCraft 2, unlike Go and chess, you can't really see the whole map and the position of each unit at the same time. Also, it requires the AI to plan ahead because cause and effects are not instantaneous, and sometimes you have to plan your strategy before seeing any results. Of course, it's a real-time game, as it's a real-time strategy game, so players are playing simultaneously, which can be complex compared to Go and chess, which are turn-based games. And last but not least, it's a large-scale game because the players have to control hundreds of units and buildings, and they play in often large environments. So all these challenges are common to the real world. So that can be really interesting for AI research. So here is a non-exhaustive timeline of some AI and games relationship. So the first I mention is Deep Blue in 1995, 1997, which is the first AI used for chess, and the first one to be able to beat a real human. So in this game, they have complete information of what's happening on the board. Also, the board complexity is 64, and the game tree complexity is 123. So the game tree complexity represents the number of distinct plays or paths for a given game. The next one is in 2016, AlphaGo for Go. Once again, AI have complete information. The board complexity is now 361, and the game tree complexity is 360. Then we have in 2016 also DeepStack for poker. This time in poker, players don't have the whole information of what's going on. So the complexity might be really difficult to determine due to these partial informations. And last, AlphaStar in 2019 in StarCraft 2. So once again, partial informations, the huge board complexity around like 18,000, because the map are the average of the map are like 136 by 136. Real-time decision and no single best strategy, which is really challenging compared to chess, for example. So more in depth, it is the first AI capable of playing the game in a professional environment and in conditions mostly similar to humans. Basically, there were a lot of AI in StarCraft 1 and 2, but this is the first one that is able to play without having like the player being handicapped or the AI having cheats or more information that the humans would have. So this is the first StarCraft AI which plays the game as in a similar way to how a human can play the game. So it is trained using raw game data by supervised learning and reinforcement learning. So this is like a sneak peek of how AlphaStar sees the game. So this picture was from the game against Mana, which is a pro gamer. But it was like a previous version of AlphaStar. I will explain later. But now AlphaStar can play using only the camera controls. So the performance of AlphaStar using raw interface and camera interface are quite similar. Despite being faster at climbing like MMR using raw interface, we can see that even with camera interface, the AlphaStar MMR is quite similar after the same amount of training days, which is 7. So it's quite encouraging for the future. And as today, AlphaStar is playing on the real StarCraft 2 ladder, and you can like play against it when you are playing like the actual game. So I will give you like some personal opinions on what can AI bring to the games as a game developer. So for me, the good points are that it can reduce manpower and fastidious tasks and improve also the process of these tasks, especially regarding NPCs or behaviors or animation, because like sometimes it will be more like easier, I should say, easier to make a proper animation or select the proper animation using AI, but also to make like more interesting behaviors with NPCs using a trained agent. Also, for me, another good point is it can add more realism and improve immersion in the game. As I said before, if you can use AI to make NPCs act more like humanly, you can expect the player to be more engaged in the game. Also, if the animation are more like natural, the player will also be more immersed into the game, into the universe. Another thing is with the new physics-based rendering, the lighting and all the aspects of the game, like the graphical aspect of the game, can add some realism used alongside proper NPCs and proper animation and so on. One point I shouldn't recommend, like I don't recommend using AI too, but it's just a personal opinion. People can disagree. It's for level design, because if you're using an AI to build the whole level design, sometimes you can miss out some opportunities to have some level design intentions and make the player experience something really different that you designed from scratch or by your own. But you can use AI partially by using semi-procedural generation. I have an example of a game called Spelunky. I don't know if they use AI, but they definitely use semi-procedural. So the level designer will like create parts of level, and a randomizer will like randomize the level using all these blocks. So in each blocks you have an intention, and combine one another, it will make you a really interesting level. So here are some resources and my sources for this presentation. So if you want to deep dive more in depth in the topics I presented you tonight, you should definitely go to these links, which are pretty good information. So thank you for your attention, and feel free to ask any questions.